All right, so the trick with number 8 here, okay, we've got a position versus time graph, and this is one of the ones I said you're probably not going to run into very often in Science 10, but you are once in a while, so you need to know how to do it. If I'm going to get velocity off a position time graph, I need to calculate what? Yeah, either the slope of the line, or if I've got multiple sections, then I need to do total displacement over total time. All right, one of the two. But for this one, it says instantaneous velocity. So that takes total distance over total time out. All right, because that only calculates average velocity. And on top of that, I don't have anything I can calculate the slope of because this is a curve. Now, what did we say a curve was made up of? Infinitely small lines, all right? Infinitely small lines that have slopes. They're not long enough to calculate. So what we have to do is draw tangent lines that will intersect the curve, not intersect, touch the curve, okay, at those points. So the first one they want is at time 2 seconds. So I need to draw a tangent line. That might be a little bit steep. Okay, that touches the curve at time 2 seconds. Luckily for me, I can adjust it. Yeah, something like that. Okay, so now I've got a tangent line. Is that long enough to calculate the slope of? Sure it is. Okay, so I just need to find two grid intersections. There's one, and there's one. Okay, so I'll have 20 over 7.5, or sorry, 20 minus 7.5 over 5 minus 1. Okay, so that's going to be 12.5 over 4. Okay. It's not going to be quite 3 this time, but 3.125. Okay, so it's close. All right. Would I give you a fair amount of leeway on something like that? I would have to. We're not all going to draw exactly the same tangent line, and as a result, not all of our tangent lines are going to have exactly the same slope. All right, so I would draw 3, okay, and I would draw one that's too steep, one that's too shallow, one that's just right, okay, just like the 3 bears in Goldilocks, okay, and then I would accept anything in between. All right, but that's how we do that one. If we want to calculate instantaneous velocity off of a curve, then we have to draw a tangent line and calculate its slope. Okay, any other ones giving us trouble? MJ? 4E? Average speed. Okay, so what do I need if I'm going to get average speed? Total distance and total time. Now, yesterday we calculated the areas of all of these triangles, agreed? Some of them were negative. If I'm calculating distance, I just take the negatives off and add all the numbers together and divide by 20 seconds. No, I can't take the lines because it's not a position time graph. It's a velocity time graph, right? So yeah, and a lot of people do that, and that's the big mistake I see on exams most often too, is people say, oh, I'll just do the lines. They don't look at what kind of graph it is, or they forget, or whatever. Okay, so yeah, make sure, guys, that you look at what kind of graph it is. And usually on an exam, I'll say in the question, just like I do here, using the velocity versus time graph, okay, at right or whatever. And on the unit exam, I would usually like boldface, italicize, underline, make this slightly bigger, okay, so that you wouldn't miss that this is a velocity time graph. All right, does that make sense? Any others? All right, keep plugging then, guys. Okay. Several parts of number 6 are asking you to calculate displacement, and a few people have noticed here that when they're drawing in all the shapes, so let's say we're doing question D here, where it says the average velocity between A and F. People are drawing in all their shapes. They're going, okay, this is a triangle, and that's a rectangle, and then I've got this triangle here, and then I've got this rectangle, okay, and then this triangle. But a lot of people are forgetting that there's a rectangle here, okay, and a rectangle here. They're forgetting about these other things. Remember that you're calculating the total area underneath the line, okay, or between the line and the x-axis. Everybody follow? I've just seen a few people, not just in this class, but in the other classes yesterday too, that were forgetting, okay, these other lower parts here. All right, so we have to remember all of them when we're calculating the area. John? Yes? I have to. It's meters per second times seconds. I have to include all of the area. This is just showing that it's accelerating, changing its speed from this to this. It still is going this fast as well, okay, with all of this area here. That all has to be included. Does that make sense? Okay. Any other ones that are giving us trouble, guys? All right, keep working then. I'm not going to be here Tuesday of next week because I'm taking the physics kids to West Edmonton Mall, and you didn't have a quiz today. So you will have a quiz on Monday, okay, which I will tweet after school today. So you have all weekend to look at it. All right. So just know that you will have a quiz on graphing on Monday because I will not be here on Tuesday. All right. So just be ready for that one. I will tweet it during the day today. No, I won't have any tangent line stuff because you can't. The graphs will be up on the board, right? You can't. I don't want you to draw them up. Okay, so on number 7 here, guys, which one in particular? What? C? Okay, so we want to find the average speed over the whole trip. Okay, if we want to find the average speed over the whole trip, we've got to find the total distance over the whole trip, which means we've got a few shapes we have to find the area of here. Okay, so we've got, okay, this triangle here, this rectangle, this triangle, okay, this rectangle, let's say just to there. All right, and we'll just use that big triangle at the end. Okay, something like that. So for this first little triangle, it is 1 base, 1 height. Okay, so it's 0.5. Okay, because 1 times 1 is 1 over 2 is 0.5. Okay, and this is 1 times 1, so it's 1. All right, this bottom one here goes from 2 to 7, so it's 5 long by 1 high, so it's 5. Okay, this one here is 2 on the base and 2 high. Over 2 is 2. This one here is 3 on the base and 2 high, so it is 6. And then this triangle here is 3 high and 2 wide, so it's going to be 3. All right, so when we add those up, okay, so we got 3, 9, 14, 17 meters as our total distance traveled. Everyone follow me there? Yeah? Okay, because it's area underneath the line on a velocity versus time graph. All right, this also just happens to be, okay, our displacement, okay, but in this case, because it was all forward, it's also our distance. Now, we have a total here of 9 seconds, so 17 meters over 9 seconds, okay, that should give us 1.94, yeah? Yeah. Okay, so that's what we're looking for there. Any other ones? Charlotte? 6D. Okay, average velocity between A and F. All right, now this happened actually quite a bit in some of my other classes as well. The issue that most people had here was they were forgetting that underneath these triangles and this rectangle up top here, there was another rectangle. And they were forgetting to calculate the area of that and add it on. Remember, it's the total area underneath the line. All right, so for this first triangle here, we've got 2 on the base by 20 high, so that's going to be 20. This one will be 40. Okay, this one's 1, 2, 3, 4, 5, 6 by 20. That's 120. This one's 1 by 20, so it's 10. Okay, this one is 3 by 20. Yeah. Okay, so that's 60. And this one is 2 by 20. So 20. Yeah, so when we add all those up, we'll have the total distance. Okay, and then we divide that by 10 seconds, and we should get, okay, our 27 meters per second. Yeah. All right. Any others? Katie? 5C. All right, average speed over the whole trip. Okay, for average speed, so we've got some shapes, again, that we have to calculate the areas of. All right, we've got that triangle, this rectangle, okay, this triangle here, and this rectangle. Now, most of the time, the people that didn't get the same answer as me just didn't agree on where this where these two triangles ended. All right, and that was, I mean, everything else they did right. They just thought they ended one more second forward or backward of where I have them. But everything is 5-second intervals on this graph. So what do we got here? 8 times 5, so this one is 40. Okay, this one should be 20. This one, or these should be both negative, right? And this one is 20, and this one is 40. Now, for C, for average speed, the negatives don't matter. All right, the total distance traveled is 120 meters, and that takes 20 seconds. Okay, so that should be 6 meters per second. Yeah. Okay, any other ones? Guess 6A. All right, so the acceleration, right? The acceleration between A and B. So I'm just going to delete everything we did a minute ago. So acceleration on a velocity versus time graph, okay? Acceleration is the rate at which you change your speed, meters per second per second. The only way I'm going to get that is if I divide my y-axis by my x-axis. If we are dividing, we're probably calculating what? Slope. Okay, the slope of a line on this kind of graph gives me acceleration. So if I want to find the acceleration between A and B, my final, okay, I'll use this point here as my y2, 0 is y1, okay, and x2 will be 2 seconds. So we'll have 20 over 2, which gives us 10 meters per second squared. Yeah. Any other ones there, guys? All right. Anybody done? I got a couple. Okay. All right. So number 9 here, guys. We've got position versus time graph, and we're trying to find average speed over the whole trip. All right. If I want to find average speed, what 2 things do I need? Total distance and total time. All right, so in this part here, he goes 500 meters, even though that graph is incredibly hard to read. Okay, 500 meters, and here he goes 250 meters, and here he goes 750 meters. So the total distance is 1,500 meters, and that happens over 500 seconds. Is that right? Okay, so that should be 3 meters per second, right? Is that okay? Was that the part you were having trouble with? B. Average velocity between 300 and 500 seconds. All right. So between 300 and 500 seconds, the displacement is negative 750. Right? And so we go negative 750 over 200 seconds, and we should get negative 3.75. Okay. All right. Any others there, guys? Michaela? 6B? All right, displacement between A and E. So we're looking for areas underneath the line here, right? Okay, and so we've got this rectangle here. All right, so the area of all of those shapes should give us our displacement between A and E. So this one, yeah, did you miss part of the? Oh, okay. All right. Any other ones there, guys? Okay.